So we continue with the next characteristics of sound, that is the pitch. Now pitch or shrillness and frequency. So pitch is related to the frequency of the waveform. So pitch is the characteristics of sound by which an acute or shrill note can be distinguished from a grave or flat note of the same loudness. It is considered only in the reference to the musical notes. Each musical note has a definite pitch. If the pitch is high, the sound is shrill, and the pitch is low, the sound is flat. In a tape recorder or a TV, the term bass and treble refers to the low and high pitch respectively. At bass, low pitch sound produced by tabla and dholak comes predominant, while at treble, high pitched shrill sounds produced by flute and ghungru, ankle bells, becomes predominant. So that is the bass and the treble which is there in our stereo. So bass will give you the sounds of the low pitch, that is the one which is like dholak and all, will be more prominent. The beats what you want, it will be more prominent in the case of bass, whereas treble is the one in which the tingling sounds like the guitar and all, they will be much more prominent in the treble part. So pitch is dependent on the frequency. So when we talk about the frequency, it will be this way. That so if we talk about the pitch, pitch is dependent on the frequency of the wave. So if you have got a waveform, two waveforms, such that the amplitude is the same. So the amplitude is the same over here. So if this is a wave which has come up here, so you will find that if the amplitude, ये जितना amplitude उतना इधर amplitude रहेगा, and if it is coming like this, so if it is this way, that you can see the frequency is more in this case, where the frequency over here is less, but the amplitude over here and the amplitude over here is the same, but then it is called as a high pitch, this is called as a low pitch. So pitch of the note depends on the frequency. Two notes sounded by the same instrument with same amplitude will differ in pitch when their vibrations are of different frequency. So if they are having a different frequency of vibration, then the pitch of the note will be different. Figure 7.19 shows the traces of two waves obtained by a screen of CRO when two tuning fork A and B of frequency 256 Hz and 512 Hz respectively are separately made to vibrate one after the other by striking them on the same force with the same force on a rubber pad in front of a microphone on the experimental setup shown in figure 7.17. Both the traces have the same amplitude and the same waveform, that is sine wave, but they differ in frequency. On hearing that during the sound of the two tuning fork, it is observed that the sound of the tuning fork B of frequency 512 Hz is shriller than the sound of frequency of tuning fork A of frequency 256 Hz. Thus, more the frequency wave of the wave, higher is the pitch, and less the frequency of wave, lower is the pitch. Very easy to understand. The pitch is dependent on the frequency. अगर frequency ज़्यादा है, then it is a high pitch sound. If the frequency कम है, तो it's a low pitch sound. That's exactly what is happening in the case of the vocal cord of males and females. The female vocal cord जो है, उसका frequency ज़्यादा है. That's why you will always find that the female voices are very shrill. Whereas the same thing in males, the vocal cord vibrations are less. Because the vibrations are less, so frequency is less. Accordingly, the sound produced by the male person is always going to be flat note. So that is how less frequency and flat note, that is how the frequency is going to be dependent on. Example of change in pitch in string instruments such as piano, violin and guitar. The frequency of vibration of string depends on the tension and thickness of the string. They can produce notes of different pitch by changing the thickness and tensions of the string. A note of high pitch can be obtained by vibrating the string under high tension or by vibrating a thinner string. So either you are going to use a thinner string for more frequency, or you are going to use a higher tension for having higher frequency. The frequency is going to depend upon, so the frequency is going to depend upon the thickness of the string, and secondly it is going to depend upon the tension of the string. So more the thickness, thinness, okay, let's say inversely proportional, or we can say thinness. Okay, the thinner the wire, higher the frequency, or higher the tension, higher the frequency. In case of flute, a lower note is obtained by closing more number of holes, so the length of the vibrating air column increases. So frequency also depend upon the length of the air column. So air column, air column. So more the air column, more is the frequency. Okay, more the air column, more the frequency. As the water level in the pitcher kept under a water tap rises, the length of the air column decreases, so the frequency of the sound produced increases. So the sound becomes shriller and shriller. Thus, by hearing the sound, okay, this will be inversely proportional because जितना air column ज़्यादा होगा, उतना frequency कम होती जाएगा. Okay, the frequency of sound will decrease with this, so it will be 1/1. Sorry, yeah. So lower note is obtained, yeah. In flute, lower note is obtained when you plug in more holes. So if it is more holes, so closing more holes means more air column. So it will be lower note. अगर मैंने ज़्यादा open रखा, तो it will be higher note. Yeah. So even in pitcher, the best thing is to remember is about the pitcher. तो pitcher जब भी भरते हैं, तो हम लोग को start means क्या होता है? The frequency of the sound increase होते रहता है. So when it is increasing, that means the frequency is directly proportional, inversely proportional to the air column. More the air column, lesser the frequency. Lesser the air column, more the frequency. So by hearing the sound of the from a distance, one can get the idea of water level in the pitcher. The voice of a woman is usually of higher pitch than that of man. Subjective nature of pitch and objective nature of frequency again is the same thing. Pitch will be related to frequency, but pitch is something which you cannot measure. It is only sensed by the person, whereas frequency is measurable. You can measure the frequency by a oscilloscope and find out the frequency and note that whether it is higher frequency or low frequency. So that's why pitch becomes the subjective quantity and frequency becomes an objective quantity. Pitch is not the same as frequency. The pitch depends on the sensation as perceived by the listener. It may be different for a sound of a particular frequency to a different listeners. That is, pitch of a subjective nature. On the other hand, frequency is a measurable quantity. It depends on the source producing the sound. It has a definite value for a given sound, which is equal to the frequency of its source. It has nothing to do with the listener. The frequency is of an objective nature. So that was about the frequency, and the related characteristics is pitch. We now see the next part, and that is the quality and the or timbre, which is related to the waveform. So I just write down over here. So loudness is dependent on the amplitude, and now comes the quality, which is dependent on the waveform. What is waveform? It is something like this. If this is a wave like this, a similar wave could be over here, which could be something like this. So you can see the waves are similar. It could be also like this. It could be even a triangular shape like this, having the same amplitude. The amplitude over here and the amplitude over here is the same. Okay. The frequency and the time period is the same. They are the same. दो यहाँ से अगर देखेंगे तो same है. Okay. So everything is the same, but the shape of the wave is different. The difference in the shape of the wave identifies it from one instrument to another instrument. Each and every instrument will give you a different kind of waveform. Sometimes it could be also like two waves connected to each other, like in the case of piano, wherein there will be one subsidiary note. So there will be multiple strings which are working over there. So because of the multiple strings, the waveform which is formed will be of awkward shapes. So quality or timbre of a sound is that characteristics which distinguish two sounds of the same loudness and pitch. The loudness and the pitch is the same, but still you are able to identify the two properly because of the emitted by two different instruments because of change in their waveforms. So quality and timbre is going to identify the two different sounds which are having the same frequency and the same amplitude, or the same loudness and the same pitch, but they are differing from by each other with a change in their waveforms. Figure 7.2 shows the wave pattern of two sounds of same loudness, same amplitude, same pitch, same frequency, but emitted by two different sources. They produce different sensation in our ears because they differ in waveform. One is a sine wave while other is a triangular wave. So the quality of a musical sound depends on the waveform. Only a tuning fork emits sound of a single frequency, monotone. So this is what is of a tuning fork. It's a single frequency. It doesn't have anything like in multiple things. Whereas piano, this is multiple things. Okay, so this is called as a monotone. Okay, simple harmonic motion. It's called as simple harmonic motion or monotone. On the other hand, sound from an instrument does not contain a note of single frequency, but it contains a combination of vibrations of different frequencies and different amplitudes. The vibration of lowest frequency and maximum amplitude is called as principal vibration, and the vibration of the frequency vibration of the frequency integer multiples of it are called as subsidiary or secondary vibration. So you can see over here that when you are having certain things like that, then the main one जिसका amplitude हम लोग measure करते हैं, that is called as the fundamental or the principal note, whereas the one which is having the multiple integers over there, which is the smaller part and all, that is called as the subsidiary vibration. The subsidiary vibration are of small amplitudes. The resultant vibration obtained by the superimposition of all these vibrations gives the waveform of a sound which we hear. So when these multiple kind of waveforms combine together and they form into a sound which we hear is basically a superimpose. Basically what will happen is the superpositioning of the sound is going to take place. They are going to get mixed up. Okay, sound gets mixed up together, and that's why there will be a superpositioning of all the vibrations, which gives the sound which we hear. Now suppose with the setup of figure 7.17, first the tuning fork of frequency 256 Hz is struck and placed in front of a microphone, and next a note of frequency 256 is produced by a piano in front of a microphone. The traces obtained on the screen of CRO for the two cases are shown in figure 7.21. It is exactly like this one and this one. You can see the figure. It is a principal note in case of the 256 Hz tuning fork, whereas it's a subsidiary note which is a musical note in the second case. The sketch A shows a pure note sine curve of single frequency produced by the tuning fork, while the sketch B is of the same amplitude and same frequency or same pitch, but it has a different waveform due to the presence of mixture of subsidiary vibrations along with principal vibration. So there is one principal vibration also which gives you the amplitude, but there are also some subsidiary notes over here. The subsidiary notes which are here, they are giving it a different waveform. The subsidiary vibrations present in the musical note make the waveform complex. It is not a sine curve. Thus, the quality of musical sound depends on the number of subsidiary notes and the relative amplitudes present in it along with the principal note. So, basically when you talk about the quality, quality is going to be about the number of different subsidiary notes which are present along with the principal note. The number of subsidiary notes which will be there, they are going to give it a completely complex kind of structure to the waveform. So that is why we are able to identify those differently even if they are of the same loudness or same amplitude and frequency. Different instruments produce different subsidiary notes. A note played by a piano has a large number of subsidiary notes, while the same note when played on a flute contains only a few subsidiary notes. Thus, we can easily distinguish between the sounds of a piano and a flute by their different waveforms, though they may be of exactly the same loudness and pitch. That is what I told you. Even if some, like for example, you can play Happy Birthday tune on a piano, you can play it on a flute, or you play it by a whistle, or you sing it out. You in all the cases, the waveform that is going to be there, the frequency and the amplitude of the waveform is going to be the same, because the tune with which you are singing or the tune with which you are playing that instrument is going to be the same. But each and every will have a different waveform. The waveform will be different, which will identify each and every kind of instrument. So it is the identification of the instrument is going to be done with the help of these quality or timbre. So recognition of source of two sounds by their quality. So let's understand how we are recognizing this thing. So each vibrating body has its characteristic waveform. This makes it possible for one to recognize the vibrating body even without seeing it. You generally recognize a person by hearing his voice on telephone without seeing him. It is because the vibration produced by the vocal cord of each person have a characteristic wave form which is different for different persons. So this is exactly why we are able to identify a person even without seeing him. I can just identify the person by the sound of the person without seeing him. That is because we are able to, each and every person is going to make a different waveform when he speaks. So on and that's the reason, that is basically what the mimicry artist does. A mimicry artist does is he's trying to produce a waveform similar to other person. That's why he sounds like, okay, किसी ने अमिताभ बच्चन का आवाज निकाला, या किसी ने there have been so many different ways the mimicry artists keep on changing their sound. So that is what they are trying to do, is they are just trying to match the waveform of that particular person when he is speaking. So that is. Similarly, one can distinguish and recognize the sound of two different musical instruments because of the different waveforms, even if they are of the same pitch and same loudness. So yeah, this is how that not only person but even the instruments, and that is very common. You know, if you are slightly good in recognizing the sounds, and when an instrumental thing is being played, you can easily identify, okay, this is the flute which is being played, or this is a guitar being played, or this is a piano being played, or this is a santoor being played. So there are so many, the instruments can easily be identified because each and every instrument has got a typical waveform of it. Okay, and that is what that waveform. Of course, we don't know the waveform, but we can identify those separately because each and every one is of a different quality. So to summarize, the table below gives the factors affecting the different characteristics of sound. So we have the factors as loudness is dependent on the amplitude of the wave. The pitch is dependent, or the factor dependent is frequency of the wave, and quality is dependent on the waveform of the wave. So this is how the characteristics of the wave, characteristic of a sound, that is the loudness, pitch and timbre of that is the quality, can be identified. So that is how the three factors, amplitude and frequency, and waveforms are going to identify the characteristics of the sound. We now move on to the next part, that is music and noise. All sounds which produce the sensation of hearing can be divided into two categories, music and noise. Okay, so yeah, you must have seen many times that suppose you are playing around in the kitchen कि वहाँ पे तुम लोग के पास जो दो spoons था उससे तुम लोग अगर कुछ बजाते हो तो okay, you certain times it is enjoyable, but certain times you find that your mom scolds you, stop that nonsense, why are you making so much noise, you know? So it means that certain kind of the frequencies or certain kind of loudness which is being produced is soothing to the ear, it is not harsh because it is rhythmic in nature, then it gives you that it is something of music. But the same thing when played in a wrong manner, or it is just being banged around, then definitely that with the same kind of utensils what you are having, the same becomes a noise because it is not rhythmic. Okay, the thing is that it should be such that it is not harsh to your ears, and secondly it should be with a rhythmic regular waveform. It should not be an irregular waveform. Okay, so If there is a regularity in the waveform, then automatically the whole thing becomes a music. But if the same thing is irregular, discordant, harsh to the sound, then it becomes a noise. So all sounds which produce the sensation of hearing can be divided into two categories, music and noise. Music, it is pleasant, continuous and uniform sound produced by the regular and periodic vibration. So there is a regular periodic vibrations which are causing it, which is it is soothing to your ears and pleasant and continuous form. For example, the sound produced by violin, piano, flute, tuning fork, etc. are musical notes, sounds. The sound level of these musical sound is usually between 10 decibel to 30 decibel. Okay, so one thing is, not harsh, regular intervals, वो सब कुछ बराबर है. साथ में the loudness, intensity, what they are talking about is the sound level should be between 30 decibel and 10 and 30 decibel. Noise, the sound other than the musical sound is called noise. Yes, if it is not music, it is noise. Okay, if anything is not music, then it is definitely noise. It is a sound produced by an irregular succession of disturbances. It is usually discontinuous sound, discordant and unpleasant to the ear. For example, the sound produced when the stone is thrown in a tin shed in a noise. So जब भी हम लोग कुछ फेंकते हैं तो धड़ाम धूम धूम करके जो आवाज आता है, तो all those things are noise. Okay, they are just noise. Usually all the sounds of the level above 120 decibel are termed as noise. So of course, apart from it being rhythmic also, if the decibel level is above 120 decibel, then it is noise, irrespective of however sweet that sound is. But it will be considered as a noise if the decibel level is above 120. Figure 7.24 shows the waveform of music and a noise. You can see the music का जो है वो एक बराबर सा sine wave है, whereas in case of noise it will be something like this, that they will be forming into something completely irregular. कुछ भी बन रहा है इधर, कुछ भी ऐसे कुछ हो रहा है, ऐसे something is going on. So you can see that in such a case they are going to be discontinuous, discordant, irregular kind of waveforms. So note, there is no sharp difference between a music and note. The difference is subjective. Yes, that's true. जैसे तुम लोगों को बताया मैंने कि if you are in a kitchen and you are playing with that spoon and the utensils, so for you it may be music. Okay, you are playing something so nicely, but for your mom who is getting disturbed at that time, definitely it is noise. So yes, noise and music can also be considered to be a subjective in nature. Like the rap song which you will be hearing may be like a noise to your parents, and the ghazals what your dad would be listening to will be noise for you. So definitely it is going to be this way, that it depends on a subjective quantity. It is depending from person to person. The difference is subjective. A sound which is a music to someone may be a noise to others. For example, pop song is a music for the young generation, which while it may be a noise for the older generation. So we can easily differentiate between the music and the noise. Music, it is regular, smooth and pleasant to the ears. So yeah, that's the main thing. It should be regular. Okay, so the waveform should be regular, it should be regular, smooth and pleasant to the ear. Whereas noise, it is harsh, discordant and unpleasant to the ears. Music, it is produced by vibration which are periodic. So they are periodic vibrations which are causing the music. Whereas noise, it is produced by an irregular succession of disturbances. Music, all the component waves are similar without any sudden change in their wavelength and amplitude. So you will find that the music always produced is such that it is always going to be in a similar waveform and without any sudden change in the waveform. So it will be quite going in a very smooth manner, that's right. Whereas noise, the component waves change their characteristics suddenly and they are of short duration. Music, the sound level is low, between 10 to 30 decibel, where sound level is higher. There is 120 decibel in case of noise. Music, the waveform is regular. Noise, the waveform is irregular. Example, the sound produced by a musical instrument is music, and the sound produced by an aeroplane, road roller, industrial machines, etc. are noise. So this is about the chapter sound. So this, with this we end the complete chapter of sound. There are totally 8 videos connected to sound, so you can just go through them completely, and in case of any doubts you can ask me. Alright, so this is about the chapter sound of physics. Thank you.